Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the IS-squared CISSP exam with focused explanations and practical context. In this episode, we're examining virtualization and cloud infrastructure considerations, two pillars of modern IT strategy that offer tremendous operational value, but also introduce new cybersecurity challenges. Whether your organization operates entirely in the cloud or manages hybrid environments with both physical and virtual resources, securing these systems is critical to maintaining confidentiality, integrity, availability, and compliance. As a future certified information systems security professional, you'll need to understand how virtualization works, how cloud services are structured, and how to secure each environment according to its unique risks and responsibilities. Let's begin with virtualization. Virtualization is the process of running multiple simulated systems, known as virtual machines or VMS, on a single physical host. A software layer called a hypervisor controls this environment, allowing each VM to operate independently with its own operating system, applications, and user base. There are different types of virtualization. Server virtualization is the most common, allowing multiple virtual servers to run on a single physical machine. Network virtualization allows virtual networks and devices to be abstracted from physical ones. Desktop virtualization delivers operating systems and applications to end users from centralized environments. Storage virtualization aggregates physical storage across multiple devices into a single virtualized pool. The benefits are clear. Virtualization improves resource utilization, reduces hardware costs, simplifies system provisioning, and enhances business continuity through features like snapshotting and rapid disaster recovery. However, virtualization also introduces new risks. Virtual environments share physical resources, creating potential for cross-VM attacks. A compromised hypervisor could allow attackers to control multiple VMS. Improperly configured VM snapshots may expose sensitive data, and managing sprawling virtual environments without proper oversight can lead to shadow IT and compliance gaps. To mitigate these risks, organizations must understand the architecture of virtualization, enforce strong isolation between systems, and implement layered security controls at the hypervisor, host, and guest levels. Now let's move on to cloud infrastructure. Cloud computing delivers computing resources such as storage, servers, networking, and software over the internet on demand. Cloud environments are typically categorized into three service models: infrastructure as a service, platform as a service. With infrastructure as a service, or IaaS, the provider delivers raw computing infrastructure, such as virtual machines, networking, and storage, and the customer manages the operating systems, middleware, applications, and data. With platform as a service, or PaaS, the provider supplies both the infrastructure and the development tools, while the customer manages the applications and data. With software as a service, or SaaS, the provider delivers everything, including applications and the platforms they run on, while the customer simply uses the service and secures user access and data. These service models are governed by a shared responsibility model. The cloud provider is responsible for securing the underlying infrastructure, including data centers, physical servers, and foundational networking. The customer is responsible for managing the security of their workloads, including data, user access, configuration, and application behavior. Failure to understand this model leads to gaps in responsibility. For instance, many cloud breaches are caused not by provider failure, but by customer misconfiguration, such as leaving storage buckets open to the public or mismanaging access permissions. Cloud environments also raise concerns around data sovereignty, compliance, and privacy. Organizations must know where their data is stored, who has access to it, and what laws apply based on the data's location. To maintain control, organizations must implement robust governance practices, secure configuration management, and continuous visibility into cloud infrastructure. For more cyber content and books, please visit cyberm.ca. You'll find bestseller books, training, tools, and resources tailored specifically for cybersecurity professionals. You can also explore additional podcast episodes and prep tools at baremetalcyber.com. Now let's walk through security considerations for virtualization and cloud, starting with hypervisor security. This is the core of virtualization. If the hypervisor is compromised, every VM on the host is at risk. That's why it must be hardened with secure configurations, regularly patched, and monitored continuously for signs of tampering or abnormal behavior. Strong isolation between VMS is essential. Virtual firewalls, network segmentation, and access control mechanisms ensure that traffic does not flow freely between VMS unless explicitly allowed. Resource controls should prevent one VMA from exhausting CPU or memory at the expense of others. In cloud environments, storage security is critical. Encryption must be used to protect data both at rest and in transit. Access to cloud storage should be governed by identity and access management systems with multi-factor authentication and strict role-based access control. Secure communication channels, such as VPN tunnels or HTTPS, must be used to protect data as it moves between users and cloud services. Logging and monitoring must be enabled to detect unauthorized access attempts or configuration changes. Vulnerability scanning and penetration testing must be conducted regularly. Scanners should assess both virtualized infrastructure and cloud services. Testing must be scoped carefully to avoid violating provider terms of service and must be coordinated with all stakeholders. Let's now discuss how to manage cloud and virtualization risks effectively. The first step is to clearly document your organization's cloud and virtualization security policies. These policies must define roles, responsibilities, usage restrictions, configuration standards, and compliance expectations. Monitoring and logging must be continuous. Virtual environments are dynamic. VMs can be spun up and destroyed in seconds. You need visibility into who creates systems, what they're running, and whether they align with security policy. Cloud-native monitoring tools and SIEM integrations help track activity and raise alerts. Incident response plans must include virtualization and cloud-specific scenarios. This includes compromised VMS, data exposure from misconfigured storage, denial of service against cloud services, or abuse of shared accounts. Organizations should also negotiate strong service-level agreements with their cloud providers. SLAs must specify availability, data retention, breach notification timelines, logging access, and response procedures. You should know how to engage the provider during an incident and what level of support to expect. Finally, staff training is essential. Teams must understand the distinctions between cloud models, how to configure virtual networks securely, and how to detect suspicious behavior in both environments. This includes both technical staff and business stakeholders who access cloud systems. Let's now turn to continuous improvement in virtualization and cloud security. Threats targeting virtualized infrastructure and cloud workloads evolve constantly. Your security practices must evolve too. Security assessments and compliance audits help identify gaps. These may include open ports, misconfigured permissions, overly permissive security groups, or unused access keys. Use findings to improve configurations, training, and monitoring rules. Post-incident reviews offer valuable insight. If an attacker exploited a misconfigured cloud service, ask what controls failed, why it happened, and what actions can prevent recurrence. Collaborate across teams. Cloud security is not just an IT problem. Application developers must follow secure coding practices. Compliance teams must ensure regulatory alignment. Legal teams must understand data contracts and regional obligations. Security teams must enforce policy, monitor environments, and lead incident response. All of these perspectives contribute to comprehensive protection. Training must be maintained and updated. As new cloud services and virtualization features are introduced, staff must understand how to use them securely. Regular workshops, micro-learning modules, and tabletop exercises help reinforce knowledge. Proactive strategies ensure resilience. Consider adopting infrastructure as code to enforce standardized, secure deployments. Use cloud security posture management tools to detect misconfigurations in real time. Apply zero trust principles to cloud workloads, treating every component, internal or external, as potentially untrusted. Virtualization and cloud computing are not passing trends. They're the foundation of modern infrastructure. But with great flexibility comes great responsibility. By understanding these environments, applying strong security practices, and committing to continuous improvement, your organization can operate safely and efficiently in the cloud. Thank you for tuning in to the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study materials, and personalized certification support. Enhance your understanding of virtualization and cloud infrastructure considerations, and will consistently support your journey towards CISSP certification success.